Okay, so part B then, you may assume it says that the equation has a root alpha between 4 and 5. Okay, so we can assume this, right? Had it not been the case where we could assume, we'd have to check what 4 is, check what 5 is, and one of them be negative, one of them be positive, so we know that there's a root. Okay, and we'd say then, oh, there's a change in sign, so there is a root there. Okay, so sometimes they'll say that to show that it's got a root, so that's what you'd have to do. But in this case, you may assume it, so we don't have to do any work there, right? We assume that there's a root between 4 and 5. And then it says use this recurrence relation here, where x0, right, this is important, the x0 bit, isn't it, is 4.7, okay, can be used to find alpha. Find and record x1, x2, x3, x4. So I'm going to write them down, okay, right, and all you've got to do here is put your answers down. Okay, you don't need to do any workings out on here. Calculate is so important. And with iteration, right, the way I always do it is the x0, the answer that they always give you to start with, the x0, is I'm going to type that into my calculator. Okay, quite simply, I'm going to put 4.7 in, then I'm going to press equals. Okay, and you get that out. Now, the reason why I've done that is because when I press ans, I'm going to get 4.7 out, right? So ans is sort of my 4.7 at the minute. So now I'm going to set this formula up that I've got here on my calculator. So I'm going to need a fraction button, 11 minus ln xn, right? So now this is going to be my recurrent x value. If I press ans, right, of course now 4.7 is going to be going in there, isn't it? Because I did that, didn't I? Put 4.7 and I press equals, so that's my answer, and I want 4.7 to go in there. On the bottom then, press the arrow down here and press 2, and then I press equals. So I get my answer now. That will give me x1. Okay. Now what's great about this, the way this is set up is, in this formula here, I can use this now for the next question, okay, for x2. But now my ans is no longer 4.7, isn't it? My ans, as the calculator knows it, is this, because this is what my previous answer is, so that's what it'll take as the answer. Not 4.7, it'll take all of this, 4.72, blah, blah, blah. So if I press equals again, right, all I gotta do is press equals. It'll give me then my x2, which you notice looks the same, but it is actually slightly different. Okay, and I write down all of that. Okay, press equals again. I get my x3, 4.7237311615, and then press equals again, and I get my x4. Okay, and you've got to write it all down, all those digits down there, and we sorted, right? That's all they wanted to do. So we can put the calculator to one side for a minute. All right. But that's how this recurrence relation works. To get the next term here, right, you've got to use the previous one, because n plus 1, using the n, the one before. So it sets it up nicely. You're using the previous answer to get the next one. Okay, that's how it sort of works, iteration. And setting your calculator up like that is ideal, okay, and it makes life a lot easier. It says then, write x4 correct to 5 decimal places. So once you've done all this, then you need to refine this then, x4, and you need to have 5 decimal places, which is 4.72370, isn't it? That's what we've got there. That's 5 decimal places. And then it says prove that this value of alpha correct to 5 decimal places. So we need to actually show that actually this is what the answer is when it's 5 decimal places. Okay, this is what it would round to. So what we do then is you get a number line. Okay, and in our number line now, we need to think about like a number line that's got 5 decimal places on it. So in the center, we put this, what we just had, the x4 to 5 decimal places. So if this was a number line to 5 decimal places, the next number then would be, okay, 4.72371. The one before it then would be 4.72369. Okay, so we're going up in 5 decimal places. What we do now is, right, we want to prove that this is the correct answer. Okay, now if I put that in, that would probably be too big possibly, and if I put that in, that would be too small. But what I need to do is I need to home in, right, I need to sort of trap this solution, okay, and I need to go in the middle here to see what this answer is, and I need to go in the middle here to see what this answer is. So if I go in the middle here, this will be 4.72370 05, if you think about it, that's in between those two. and in between these two it would be 4.72365. Okay, so those are two answers I'm going to check, and I need to go back to this up here, right? I need to go back up to the original function they give me up here. Alright, so I'm going to call, let's say, f of x. We don't use the recurrence relation for this bit, use the original function. Okay, so I'm going to call it f of x, and I just need to type this number in now, 4.72365. I need to put that in there, right? Okay, and that's what I'm going to type into my calculator. So ln 4.723695 plus 2 4.723695 minus 11. So I get out then this answer. It's negative, isn't it? 1.86 times 10 to the minus 5, right? Rough answer there, that'll do. Okay. All I want to show is that there's a change in sign. So then if I do the next one, okay, so all I'm going to do then is change this to 705 there, change this one, go back, and I get positive, look, okay, 3.44 times 10 to the minus 6. So one's negative, one's positive, so there's a change in sign. Now this was negative, wasn't it? This was positive, so what that means is the solution is somewhere there. Okay, between these two, the solution is somewhere there between these two. It will round to this then, to 5 decimal places. So change in sign, therefore x equals 4.72370 to 5 decimal places. Okay, so we've shown there's a change in sign.